when we do this one off to the side. So here's our steps. Number one, we're going to use the factor theorem. Step two, we're going to use synthetic division with that factor. Once you get your answer, we'll write our division statement. That's your Dairy Queen statement. And the remainder will be 0 if it was truly a factor. And usually you'll have an x cubed one, which will leave you an x squared one, which you can factor normally. Sometimes, though, with what you get, you'll have, if it was an x to the 4, then it would leave you with an x cubed, and then you're going to have to repeat steps 1, 2, and 3 again with a new polynomial. So basically, for step 4 here, we're going to factor again until we're finished. And sometimes that factoring again till you're done means going back to step 1 and using the factor theorem again. Often, at step 4, you're going to have an x squared, and then factoring again just means factor like you used to factor with x squared. This one, starting with an x cubed, will leave us with just an x squared. So for this one, we're looking at our constant term. Our constant term is a 2. The factor theorem and the factor property says that if there is something that factors nicely, it would have to be a +1 or a -1, or a +2 or a -2. So I'm going to call this P of x, just so that we don't have to write it out over and over again. So step 1, we're looking at our possible factors. ±1 or ±2. There's not that many to try. Which one do you want to try first? 1, -1, -1. Plug it in. 3 times -1 cubed minus 4 times -1 squared minus 5 times -1 and +2. -3 minus 4 plus 5 plus 2 is equal 0. Yes. So that means in this one, worst case scenario, you try 3 of them and they don't work until the 4th one finally works. If you tried them all and they don't work, it means that it can't be factored. That would be a very nasty question to have on a homework assignment, especially if the last number was, I don't know, like 108. So you'd have to try like 1 and 108 and 2 and 54. And could be quite nasty. So now we've done step 1. We've found one of our factors. We can go to step 2, which is using our synthetic division. Our coefficients were 3, -4, -5, and 2. Bring down the 3, multiply 3 by -1, add. Negative 1 times 7 is 7, add. And it looks like our original mental math in step 1 was correct because we get a remainder of 0. So now we can do step 3, which is our division statement. Since I called my polynomial above p of x, I can say p of x equals here. If you didn't write and you didn't clarify what p of x is, like what I did at the beginning here, I should probably even say let p of x equal this so that I've defined it. Then I can write it later in the question. If I didn't define that, I would have to rewrite this whole thing out. You have to write the division statement after you've factored because this will show that x plus 1 times 3x squared minus 7x plus 2, because you want to factor it completely. Like right at the very end? Like, so in other words, you're just going to write this and then factor that and then write your statement in the end. That would be fine as far as showing your work. I would prefer if you showed this as the next step because it's not hard. Then step 4 is factor completely. Now we have a binomial here. To get 3x squared has to be 3x and x. To get a 2, it's going to be 1 and 2, but I need to get a 7, so I'm going to put the 2 here so it gets the outside of 6. And 1, that will make 7. If they're both negative, I'll get my negative 7, and I'll get a positive 2 at the end. And now it's factored completely. So the questions you can do for this one are 5, 11, 9, and 10b.